In this video we're going to look at the instrumentation amplifier. So this is a very popular amplifier. It's really stable and accurate, and it's got a really high input impedance. It's a very popular amplifier. So we can build it up here using 3 op amps. So op amp 1, 2 and 3. We've got our input voltages V2 and V1 and our output voltages V0. So it can be split into 2 sections really. There's a buffer section here and an amplifier section here, and we'll analyse that by splitting it into those 2 sections. So we'll call this point here V2 dash, okay, the voltage there V2 dash, and we'll call the voltage there V1 dash. And we know that the rules of an amplifier, op amp tells us that the voltage V2 should equal the voltage at VB, and the voltage at V1 should equal the voltage at the point VA. So it means that we can go from V2 down through RF to voltage V2 dash, sorry, through RF to voltage V2, down through RG, and then at this point here is going to be equal to V1, and we'll go across to RF to get to V1 dash. Now if VB doesn't equal VA, there must be a current down through that resistor RG. Okay, so let's have a wee look. We'll split that up just like that. So we've got V2 dash goes down through RF onto RG and through the other RF back to V1 dash, and the voltage across that RG is the input voltage V1 and V2. So what we're going to do is we're going to find V2 dash in terms of V1 and V2. We're going to find V1 dash in terms of V1 and V2, and then we can subtract them off, and then we're able to then go and find the output voltage in terms of the input voltages. So let's just do that now. So V2 dash is going to equal the voltage at V2 plus the volt drop across RF. Okay, so it's V2 plus IRF, and the same again here, that the V1 dash is going to equal, well, it's going to be V1 minus the volt drop across RF here, which is minus IRF. And we know that the if we take this first one here, we can write V2 dash equals V2 plus, now the IRF is going to be RF times the current I. Well, the current I is just going to be equal V2 minus V1 upon RG. Okay, that will give us a current through that network. And similarly here we'll have our V1 minus RF, V2 minus V1 upon RG. Now when we subtract this off one from another, we're going to get V2 minus V2 dash minus V1 dash equals V2 minus V1, and that's going to give us this one here minus the negative of that one, which is going to be that plus it, so you're going to end up with 2 RF upon RG V2 minus V1. Okay, so then we can rewrite that there, and we can say our V2 dash minus V1 dash is going to equal our 1 plus 2 RF upon RG V2 minus V1. So finally then we can say that our V out is going to equal R2 upon R1 VA minus VB. Now we're making the assumption there that the resistors are in ratio R2 upon R1 is the ratio of R4 upon R3. So that's a little proviso there, that it needs to be sure that that's true in order for the design to be correct. So finally we can say that the V out is equal R2 upon R1 times 1 plus 2 RF upon RG V2 minus V1. So the gain you can see here of this is going to be R2 upon R1 1 plus 2 RF upon RG. Okay, so again you can read through that and do the derivation there and convince yourself that that is in fact the case. Okay, so I've built this in Multisim, and you've got access to it in the sections there. Okay, so you will have access to this Multisim simulation there. Now we've got our 3 op amps here, and we can see that our inputs here are a 1 volt peak and a 0.5 volt peak, so it should take the difference between these and then amplify it by a gain. Now you can see that we've got an input here in blue, and we've got another input that is in red. Okay, so the input in blue is about half a volt, and the input in red is 1 volt. So the difference between these is half a volt. And if you check out the resistor values and you check out the gain equation in the last page, you'll see that this has got a gain of 3. So it takes the difference between the red signal and the blue signal, which is half a volt, multiplies it by 3 to give us 1.5 volts. Okay, so it does work, and you can download it and have a wee go and try it for yourself. So that's all there is to this section on some basic op-amp designs. I really put this section in so that we could get used to using the multi-sim, and also we get used to just analysing op-amp circuits. So we haven't looked at anything to do with the frequency response of op-amps, and now we're going to start moving on to that. But first of all, we'll go and have a wee look as a recap and a reminder on Laplace transforms. Okay, so thank you for listening and goodbye.